All right, we're back to the question of the pumpkin time bomb, and this will be the last time that we look at the data from the pumpkin time bomb. What I've got here is the scatter plot, and you've seen it before. And what we're going to do now is apply what we've just learned about analyzing our scatter plot, and we're going to calculate the line of best fit, and we're going to calculate the r and the r squared value to see how strong of a relationship, if any, there is between the number of elastics and the diameter. You may have already decided whether or not there should be a relationship or whether there is a relationship between these two things. I've got the independent variable, the diameter, on the x-axis, and the dependent variable, the number of elastics, on the y-axis. Be very careful when you're choosing your independent and dependent variables. The diameter obviously here is the independent variable. Over to the left, I've given you some, not all, of the data that was collected by various schools when they tried this experiment. Unfortunately, we can't do that, but if you want to try it by yourself at home, be my guest. So you've got a number of variables there that are labeled x and y, x representing the diameter and y representing the number of elastics. And what I'd like for you to do is take those numbers and feed them into the equations that you learned yesterday in order to, number one, calculate the equation of the regression line, which is just another way of saying find y equals mx plus b for the line of best fit. It's really just the same linear equation that we've been using since grade 9. The other thing I want you to do is once you've done that, I want you to calculate r squared, and I want you to calculate r. R squared and r will tell us how strong of a relationship there is between the two variables. And I made a note earlier in this section to just kind of warn you of a common mistake that I see that students make a lot. If you calculate r squared using the formula, then what a lot of students like to do is then take the square root to find r. And that's okay, because that does give us our value. And that's the quickest way to get there instead of having to go through that big long formula to get it. But the thing that you have to do next is use your own intuition, your own common sense, and determine whether or not r is a negative or a positive value. It doesn't show up if you're going to take the square root. Most people forget that when we take the square root of a number, such as 25, let's say, that there are two possible answers. Plus or minus 5 squared will give us an answer of 25. And most people just take the positive square root. If we do that in this case, what we're leaving out is the fact that this relationship could be a negative relationship or an inverse relationship. As one thing goes up, the other one goes down. And so you need to look at your line of best fit in all of your data and just make sure that your sign, your positive or negative sign, is correct for r if you've chosen to take the square root of r squared in order to get r. Once you've found all of that, I want you to go to the discussion board and I want you to talk about your results and what you think is the relationship. The overall question here, the reason that we do all these statistics and the reason that we do all this analysis is that we're hoping that this equation will allow us to predict the number of elastic bands for any diameter of pumpkin that we do this with. I've also seen this done with watermelons. If we can come up with an equation that allows us to predict something, then it saves us having to do it experimentally every single time. Obviously, that's a huge time saver. So what we're looking to do is answer this question: can we safely predict the number of elastic bands that we would need for any diameter of pumpkin? Depending on whether or not r and r squared are strong numbers or weak numbers, then we can answer that question, and that's what I'd like you to go to the discussion board and talk about. You'll also find a link to the data and the scatter plot on the lesson as an attachment. So just hit more details in the Google Calendar box, and then you'll see the attachment. When you open that up, you'll see everything that you see here on this screen.